So the power profile for wearable devices or IoT devices is quite unique. There's a significant amount of power expended in sleep modes because the devices are spending a lot of their time in sleep. And there's also a significant amount of power expended in active modes, such as measurement modes or transmit modes. So in both of these cases, the power management IC has to help extend the battery life in both of those types of modes, the sleep and active modes. What we have here is a demo of one of our power management ICs for such a system. And right now I'm showing you that we have the PMIC running with 1 buck activated, and we have a fairly slow quiescent current of around 4 microamps. But as I add different regulators and turn those on, you can see that for the switching regulators, it actually adds approximately 1 microamp per regulator, and even less for the LDOs that get integrated. So even when there's a lot of regulators on in the system, the quiescent current is so low that they're not drawing that much, helping to extend the battery life in sleep mode. But then of course you have the measurement and transmit modes where you're active. And here you need efficient regulators. Here you can see buck 1 is running at 89% efficiency with a load of 100 milliamps and a peak current in the inductor of 175 milliamps. Buck 2 also up at 90% efficiency. The boost here set at 90%, 89%, 88% efficiency for a 5-volt load. So when you're in the active and transmit modes, you are actually also saving power because of the high efficiency regulators on these PMICs. The third thing that has to be considered in these kind of systems is the switching frequency of those regulators. What we do to address that is we basically have all our regulators switching at one particular frequency under a certain load. For a load of 100 milliamps, we have a switching frequency of approximately 790 kilohertz with a peak current in the inductor of 250 milliamps. If I change that peak current to say 175, I can move that switching frequency to 1.4 megahertz. In addition to regulation, these PMICs also help with other system management functions on the device. We have current sinks that can sync the power for LEDs. I have here the buck boost used, say, for a green LED on an optical sensing of heart rate on the wrist, or the high voltage boost, which goes up to 20 volts, can be used to power backlighting or display options on these wearable devices. And finally, we also have a haptic driver integrated that can drive either an ERM actuator or an LRA, so that you can haptically give information to the user on the wrist through vibrations for different events or different occurrences that you wish to report to them. Thank you.